Welcome student for this subject computer integrated design and manufacturing. So we have the first unit, that is computer graphics. So in the first unit we are going to learn the basics of the computer aided design and some basic geometric transformations, and finally the geometric mapping. So in the today's lecture we are going to cover some part of these points. Computer aided design we can define as the use of computer to assist the user in the design of the system. So computer is used in the design and it is used to assist the designer, and this can be achieved to have the following functions which can be done with the help of this computer. So first is to create, and second is to modify, then analyze, and finally the optimize. So with the help of this computer we are going to create the drawing, we are going to create the design, then the modifications will be there. Modifications can be done very easily because of the use of the computer. Then analysis can be done with the help of the softwares, and the optimization, lot of softwares are having this separate tool, that is optimize tool. So with the help of this optimize tool we can easily optimize in your drawing. So all the present day CAD system are user friendly and they are based on the interactive computer graphics. So this interactive computer graphics will display the data and information in the form of the graphics. Then we have the next one, that is computer aided manufacturing. It is the effective use of the computer system for planning, managing and controlling the operations of the manufacturing plant. So we can say manufacturing activities can be planned, it can be managed, it can be controlled, and this can be done by using the computer, which is used widely in the nowadays activities. Typically we can say the application of the computer aided manufacturing can be divided into the two broad categories, that is manufacturing control and the second is manufacturing planning. So these categories represent two different levels of involvement of the computer in the operation of the plant. Then let's compare the traditional and computer aided design process. In the traditional design process we have the 6 phases as shown in the figure. So starting from the recognition of the need, then defining the problem. So this is the part of the market survey. So this input we are getting from the customer or from the market. Then next 4 phases we can have synthesis, analysis and optimization, then evaluation, and finally the presentation. Now these are the traditional design process that we are having for our component. Now in the computer aided design process, the last 4 phases of the traditional design process can be very well performed with the help of this computer aided design. So these last 4 phases we can say synthesis, analysis, evaluation and presentation, this we are doing with the help of the computer. Now first is your geometric modeling in the computer aided design. In the geometric modeling phase it corresponds to the synthesis of the traditional design process. So the geometric modeling that can be done with the help of the 3 different models, that is wireframe model, then we have the surface model, and then we have the solid model. So any of these can be used as per the requirement. Then the engineering analysis can be done with the help of the tools, that is finite element analysis we are having, then ANSYS we are having. So with the help of this tool, FEA or ANSYS, we can do the engineering analysis. Then we have the design review and evaluations that can be done with the help of the computer aided design. And one of the major advantage of the computer in the design process is the accuracy that we can get in the design process. Then we have the computer aided drafting. So in the computer aided drafting we can present the design in the form of the drawing. So we have the different drafting softwares available. For example, we have the AutoCAD software for representation of the design. So this is what the difference between your traditional and computer aided design process that we are having. Then we have the difference between your traditional manufacturing and computer aided manufacturing. In traditional manufacturing, you can see that we have the different structure. The structure for the traditional manufacturing is shown in the figure. The process planning is there. Then we have the tooling and equipment we are having, production scheduling. Then we have the production, and it can be controlled or it can be checked with the help of the quality control techniques. So production, we can say production is nothing but conversion of the raw material into the finished product. So we have the different manufacturing or different production techniques are available, and we can have the quality, or we can check for the quality with the help of the different quality control techniques. So these are our traditional manufacturing. And then we have the computer aided manufacturing. In the computer aided manufacturing, basically we have the computers used widely in the manufacturing activity. We have the process planning with the help of the computer, then the material requirement planning, computerized scheduling also there, computer control robots and the machines, and then computer aided quality control. So these computer control machines, we have the CNC machines, vertical machining center, horizontal machining centers. Even we are using the robots in this computer control with the help of this computer control machine. So these robots are used in the hazardous environment where your worker cannot work for your operations. So in that case, we are using widely the robots in the manufacturing. So this is what the difference between your traditional and computer aided manufacturing. So basically in the computer aided manufacturing, we are using the computers in the manufacturing, and with the help of the use of the computer, it is observed that the production rate is greatly increased. With the increase in the productivity, the quality of your manufacturing is increased, and your output is also increased. So in this era of the competition, to survive, lot of companies are preferring this computer aided manufacturing rather than the traditional manufacturing process. Now let's see the different input and output devices for the computer. So we have the keyboard. Keyboard is the commonly used input device for the computer. Then along with the keyboard, we are using the mouse also as one of the important device for the input to the computer. Then light pen is a device, it will select the screen position by detecting the light coming from the points on the screen. It works on the principle of light rather than the ink. Light pen is not actually used for writing something on the screen, but it is used for detecting the position on the screen. Then we have the joystick. Joystick is used to control the on-screen cursor movement as your cursor, as your mouse is controlling, or as your mouse is functioning. Okay, so on-screen control can be done with the help of this joystick. The response of the joystick is quicker as compared to the other cursor control tracking devices. Hence, they are more suited for video games. You will see a lot of video games, they are using the joysticks for controlling the movement. Then next we have the digitizer. Digitizer is used for converting the physical location into the coordinate values, so that the accurate transfer of the data can be achieved. Scanner also we are widely using as the input device. So we are getting the JPEG image from the scanner, we are getting the documents that can be scanned from the scanner. Okay, so we can save this document in the different forms, in the PDF form. Okay, so all these what I can say can be done with the help of the scanner. So these are what the different input devices, and as per our requirement we can use the input device for the computer. Okay, keyboard and mouse is widely used as an input device in the computer, and other devices can be used as per your requirement or as per the application. Okay, now let's see the various output devices that we are having. So we have the different display devices. Cathode ray display tube, we are having CRT, plasma panel display, then we have the liquid crystal display, that is LCD. This cathode ray display is not used nowadays. Plasma panel display and cathode ray display, it is totally replaced by the LCD, that is liquid crystal display. Even our televisions are also having this liquid crystal display nowadays. Computer screens are having this liquid crystal display. Then we have the different hard copy devices like printers, then plotters we are having, then we have the photographic devices. So all these are the hard copy devices that we are having. So these photographic devices are essentially the cameras that we are using in front of the your display devices. Okay. So with the help of these cameras we are doing the recording. Okay. So these are what the display devices, and we have the hard copy devices. Okay. Then third, we have the storage devices. For storage purpose, we are using the floppy disk. Floppy disk was used in the early days, but nowadays it is not used because of some limitations. So it is replaced by the CDs, that is compact disk, and we have the advanced version, that is digital versatile disk, DVD. So lot of capacity is increased in the DVD. Even we can store the movies, videos very easily in the DVD. We have the magnetic tape for the storage device. So in the NC machines we use these magnetic tapes, and we have the tape reader for the numerical control machine, so that whatever data is there on the magnetic tape, so this data can be read by the tape reader on the numerical control machine, and accordingly your machine will work. So this magnetic tape we are using for giving the input to this numerical control machine. So these are what the different input devices and the output devices that we have seen. Okay. So as per our requirement, we can use these devices as an input and the output device for your computer. Then let's see the geometric transformations now. Okay. So these are what the basics we have seen about the computer. What is a computer aided design? What is a computer aided manufacturing? How your traditional design and manufacturing that we have compared. Then we have seen the different input devices and output devices for the computer. Now let's see now the geometric transformations. We'll see first what is the geometric transformation and what is the purpose of this geometric transformation, and one by one we will see the basic geometric transformation that is to be used. So one of the major advantage of this computer graphics or computer that we are using is the alterations that can be done in the drawing. Whatever drawing we are making on the computer screen, so this drawing can be easily altered or can be easily changed. So that is what the one of the major advantage. Something, suppose you are given the dimension of say 100 mm and you want to change it to the 90 mm, so you can easily change it. Okay, you can easily change the shape also, or you can easily change the dimensions. So that is what the advantage of the computer graphics. So these alterations can be done very easily in the drawing with the help of this computer graphics. That is the one big advantage in this graphics. So these changes are very easy to perform as the graphic image. Why we are changing this dimensions or the shape? Because this graphic image has the database. This database is created for it, and whatever changes we are making in the database, so these changes in the database will be reflected in the drawing on the screen, we can say. So whatever you see, your changes made on the screen, you will see in the fraction of second you are getting these changes. But how you are getting these changes? These changes are made because of the database, whatever database is created for your drawing. So any drawing you are making on your screen, so for that drawing the software will have the database created for it, and because of this database we can easily make the changes, or we can easily alter the position or the size of the image. So this database can be modified by mathematical operations. So what we are seeing, the transformations. So this database we are going to modify with the help of these basic geometric transformations that we are going to see. So these transformations will use the data which is stored in the buffer, frame buffer, and these modifications of the data will result in the modifications of the display. We will see that. Now let us see how the geometric transformation will work. We will take the example of the line P1, P2, and we will see how these modifications can be done in the line or the point. A point can be represented by a one row and the two column matrix. Okay, so in the geometric transformations we can say, you take the example of the point P xy. So P xy can be represented, we can say, with the one row and the two column matrix. Okay, so this is the representation of the point P. So simply point P, we can say it is represented by the one row and the two column matrix. Now take the example of the line. So this line can be represented by 2 points. We know P1 and P2. So we have the P1 x1 y1 and P2 x2 y2. Okay. So this line P1 and P2 can be represented by 2 row matrix and 2 column matrix. That is P1, that is x1 y1, and P2 x2 y2. Now any change in the position of the line or in the size of the line, so this can be made by making the changes in the matrix. So this matrix we can change x1 y1, x2 y2. You change the coordinates of this x1 y1 or x2 y2, accordingly your position of the line will change. Okay, P1 P2, your line position will change as you make the changes in this database. So this line P1 P2 will have the database created for it, and how this database will be stored? This database will be stored in the matrix form as x1 y1 x2 y2, 2 column matrix and 2 row matrix. So whatever changes you are making in this database of 2 column and 2 row matrix, accordingly these changes will be stored in your software or in your database, and whatever changes you are making in this database, it will result in the modification of the display. So this is what the representation of your line or the point. Then we have the basic geometric transformation. So we will see some basic geometric transformation one by one. So first is your translations we are having, then second we have the rotation, then we have the scaling transformation, then the reflection, it is also called as the mirror, and then finally we have the shear. Okay. So these are the basic geometric transformations we are having, and one by one we will see these transformations. So first let us go for the translation. So translation is a simple transformation, and we will see how the translations is done. In the translation, the geometric model remains parallel to its initial position. So whatever is your initial position, to that position your final position is there. Okay, or the geometric model is parallel to its initial position. That is what your translation. Okay. Now this indicates that that every point on the model will be moved by equal given distance in a given direction. So when your model is parallel to its initial position, we are moving the model by equal distance and by in a given direction. So translations we can say it involves the moving of an element from one location to the another location. So this element will be moved from one location to the another location such that it will remain parallel to its initial position, and it is moving, every point will be moving by an equal distance and in a given direction. Okay. So this is what your translation is there, and we will see how these translations can be done for your image. Now for this, consider a two-dimensional point P having coordinates x, y. So we have the point P with the two coordinates x, y. Now for translation of this point P, x, y, let's see, Tx is the moment in the x direction and Ty is the moment in the y direction. So we have the translation matrix T, that is Tx, Ty. Tx is the translation moment in x direction and Ty is the translation moment in y direction. Now to translate this point P with this moment Tx and Ty, simply what we are doing, we are adding this translation matrix to the original matrix. You can see now. P dash is your final position and x dash y dash is the final coordinates, and this P dash will be what? P is the original position, that is xy, and T is the translation matrix, that is Tx and Ty. So this x dash will be obtained like this. X dash will be what? X plus Tx. So this x and Tx, when we are adding this x and Tx, we will get the x dash, and y dash we will get by adding the y and Ty. When this y and Ty is added, we will get the y dash, that is position P dash. Okay. So in this manner, we will get the position P dash, that is x dash and y dash. Now we can see that this translation can be obtained by simply adding the translation matrix to the original matrix. Okay, so simply we are adding the x coordinate to the x position and the y translation to the y position. X dash will be x plus Tx, that is translation in the x direction, and y dash will be y coordinate plus translation in the y direction, that is Ty, y plus Ty. Now let's consider this with the help of the simple example, how the translations can be done. Let's consider the triangle A, B and C, and this is to be translated by the 4 units, that is Tx will be 4 in the x direction and 2 units in the y direction. Okay, that is Ty will is equal to 2. Okay, so Tx will be 4 and Ty is equal to 2, and we have the translation matrix like this, Tx and Ty, we have the 4, 2. Then the final position will be A dash, B dash, C dash, and this final position will be equal to the original position ABC plus the translation matrix T. So A dash, B dash, C dash will be equal to ABC plus T, that is the translation matrix. Then we can get this simply by adding translation matrix to the original matrix. So you can see now x coordinate will be added to the x position, and y translation will be added to the y coordinate. Okay, so this 4 is the Tx and 2 is the Ty. Add this 4 in the x coordinate and this 2 in the y coordinate. So you will get the new position of the triangle ABC, that is nothing but A dash, B dash and C dash. You can see here, simply by adding this Tx and Ty in the triangle ABC. Okay, so you will get the new position A dash, B dash, C dash, that is 5, 2, 7, 5 and 8, 3. Okay, and initial position is what? 1, 1, 3, 3 and 4, 1. Now let's represent this final position with the help of the drawing. You can see here, your initial position of the triangle A 1, 1, B 3, 3 and C 4, 1. Okay, so this was your initial position. Now we obtain or we translated this triangle by 4 units in the x direction and by 2 units in the y direction. So triangle A, B and C is translated to the new position A dash, B dash and C dash by how much amount? By translating in the x direction by 4 unit and y direction by 2 unit. Okay, so you will get the final position, this one. How we can obtain this? By adding the 4 to the x coordinate, by adding the 2 to the y coordinate. Okay, so this is what your final translation that we are getting for your triangle A, B and C. Now what we can see in this translation, in this transformation, every entity is parallel to its initial position. Okay, every entity is parallel to its initial position, and every entity is moving in the same by equal distance from its initial position. So A dash is moving equal distance from A, B dash is also moving equal distance from A, and C dash is also moving equal distance from C. So this is what your first transformation, that is the translation, and translation is a common transformation that you can see. And how to obtain this translation? The translations can be obtained by adding the translation, whatever translations we are having, to the basic coordinate, that is x coordinate and y coordinate. So whatever translations movement we are having, translation in the x direction and translation in the y direction, so these translations we are adding in the original coordinates so that we can get the new position. So students, in this lecture we have seen the introduction of the CAD system, then the difference between your traditional design process and the computer aided design process, then the difference between your traditional manufacturing process and the computer aided manufacturing process. Then we have seen the various input devices and output devices for your computer, and we have seen the geometric transformation, what is the purpose of geometric transformation, and we have seen the one geometric transformation, that is translation. Thank you.